Hello, this is Brianna, and today I'm going to be showing you how to do question 4 and question 5 from our practice final exam for Calculus 2. So question number 4 asks us, oh, where is my cursor? It's not wanting to pop up for me. Oh. Sorry about that. It is asking us to evaluate the integral from of x to the fifth by sine. Now, you might be looking at this question and thinking we can do integration by parts, which is 100% correct. But if you were to do integration by parts, you would have to do integration by parts like 6 or so times, which would take a while. So our professor taught us the amazing tabular method, which honestly I love as one of my favorite things we learn in calculus because it is very easy. So when you are doing the tabular method, you are going to be finding your u and your dv, right? So whatever your dv is, you're going to be integrating, and whatever your whatever your u is, excuse me, you're going to be deriving. So we're going to say our u is equal to x to the fifth, and we're going to say, and let's switch this color to something a little bit darker so it's easier to read. We're going to say our dv is equal to sine of 2x. Cool. So now we're going to start our tabular method. So let's make a table. As the name implies. Tabular table, you know, makes sense. Cool. So we are starting with x to the fifth in this column, right? So this is kind of our thing that's going to set how many terms we have, right? Because when you are defining what your u is, you're going to want to pick a value that is eventually going to reach 0, right? This value, if you derive it enough times, will eventually reach 0. So that's why we've picked it for our u value and why I am working with this term first, right? So when we derive x to the fifth, we get 5x to the fourth. When we derive that, we get 20x to the third. When we derive that, we get 60x squared. And when we derive that, we get 120x. When we derive that, we get 120. And when we derive that, we get 0, right? I hope we all know our derivatives. If we are watching a Calc video, I'm going to assume we do. I hope we do. Watch a quick Calc 1 video about derivatives. That is very simple derivative. So I'm sure you can learn it quickly. It's just whatever the power of x is times the coefficient in the front, and then subtract 1 from the power of x after you've done that. Cool. I don't know why I just explained derivatives. Okay. So now we're going to have our dv term, which is sine of 2x, right? So the integral of sine of 2x, I should probably hold up just make sure I don't mess anything up. Sorry about that. I thought I had the message in it, but apparently not. Cool. Okay. The sine of 2x is going to be negative cosine 2x, and whatever is in here, we're going to be dividing the term by that. So divided by 2. The integral of negative cosine 2x divided by 2 is negative sine 2x, and then and then this divided by 2 is going to be 4, turn to over 4. Now the integral of this is going to be positive cosine 2x. Again, this divided by 2 is going to be 8. Then we are going to get the integral of that is just going to be sine 2x. And this divided by 2, which is going to be 16. Then it's going to be negative cosine 2x divided by 32. I think you kind of get the flow at this point. Sine 2x divided by 64. Cool. So now the last kind of part of the tabular method is our signs. Okay, so it just alternates every term. There's nothing really else more special than into that. But it starts with plus, minus, plus, minus, plus, minus, plus. Cool, cool. The only weird part of the tabular method that you have to make sure you remember is you don't multiply them straight across. You multiply them together like this. Okay, I'm gonna do a few different colors just to make it very clear what I am multiplying together. Okay, so whatever's highlighted, we are multiplying together. Okay. All right. Cool. I'm going to scroll down a bit because this is going to be very long. Tabular method, it is a pretty long thing. All right. Well, sometimes. Yeah. Something to fit in, or it's going to be. I think they're trying to break zero. Anyways, so x to the 5th times negative cosine 2x divided by 2 times positive sign is going to be negative x to the 5th cosine 2x over 2 times. These are multiplied by each other. Okay. Negative times a negative is a positive, so we're going to have plus 5x to the 4th times sine 2x over 4. Positive times positive is a positive. 20x to the 3rd by cosine 2x over 8. Also, something just to take note of, these all have different powers of x, so we can't add these terms together, which is very nice because once we write this all out, that is our answer. So negative times a positive is a negative. 60x squared times sine 2x over 16. Positive times a negative is a negative. 120x cosine 2x over 2. Okay. And then we're going to have negative times a negative, which is a positive. 120 sine 2x over 64. And of course, our last, most famous, and often most forgotten term, plus c. Okay. So, sorry, drop the pen. Okay. This is the solution for number 4 on our practice final exam. Utilizing the tabular method, which is kind of just a shortcut for integration by parts when you have a long expression, when you have your u's to a high power. So, yep. Now I'm just gonna erase that real quick. Now we can move on to number 5 is what I believe I was going to do next. Yes, okay. That was my plan. All right. Number 5 asks us to solve the integral of secant fourth power x times tan to the third power x dx. And it's an indefinite integral, so remember we're gonna have that plus c at the end. Anyways, so for these trig functions, you really just have to make sure you know your trig rules and kind of just play around with it in your brain. When I was taking the exam, I kind of didn't do it the most straightforward method because I was kind of just writing out the terms in different ways. Here, I'm going to be doing it the condensed version, not write out the terms in a million different ways before my brain finally sees the best method of attack. But yeah, you kind of just have to think it through and see like what you have to change and how things will cancel out, whatever. Usually when I see something like this, I know one of these terms is going to have to change either with the power reducing formula, which is with one of our like normal trig formulas, or and then like utilizing like things like the substitution method, which is exactly what we ended up doing in here. No power reducing formulas. Power reducing formulas probably more we had like a cosine in here, right? Because our power reducing formula gets us stuff in terms of cosine. And it would be like over 2. So that would also throw off that. So we don't want that for this one. So, but we can separate this into secant squared x times secant squared x. And then I think I just did, and then we can just leave tan third like that. All right, so the reason I separated it like this is I want to use one of our trig identities. That's what I was thinking of earlier, but I cannot remember. So secant squared x is equal to 1 plus tan squared x by secant squared x tan cubed x dx. Now you might be wondering why I left this secant squared x here, and it's because now I'm going to be substituting the tan, right? Because remember, when you substitute it, then you have to find what your du is, and our du is going when you derive tangent, it is going to be equal to secant squared x, right? So that's going to end up canceling out, right? So our u is equal to tan x, meaning our du, which is the derivative of u, is equal to secant squared x dx, and our dx is just equal to du divided by secant squared x, right? So now let's plug this stuff in. So we have the integral of 1 plus u squared, right, by tan cubed is u cubed, and then times secant squared x du over secant squared x, right? So then these are going to cancel, right? Makes sense so far? I think I'm doing a half decent job explaining it. 1 plus u squared times u to the third du, right? So now what we're going to do next is we're going to multiply this u cubed on through. So this is going to be equal to the integral of u cubed plus u to the 5th du, right? So now we get integrate. So this is equal to u to the 4th divided by 4 plus u to the 5th. Oh, sorry. U to the 6th. I know my 4s and my U's look the same. I'm trying to make it better. Okay. Over 6. Let's see. If you want, you can look that. Just add it in at the end. I think it's probably better if I add it now. Okay, cool. Now we're almost there. We just have to undo our substitution, right? So our U is equal to tan x. So we have tan to the 4th x over 4 plus tan to the 6th x over 6 plus c, which is our answer for this problem. Cool. So number 5 on our practice exam, it's this, and this is the full solution. Not too bad. I can get this to show it. Cool. Yeah. So that's all for this video. Thank you for watching.